We're still pursuing our product. Now we pursue our product rule. We have gotten this, the derivative of this. We know the derivative of this. Now we apply product rule and then we get that. By applying product rule, we have dy by dx is nothing but, we differentiate this keeping this constant, but when we differentiate this we get 1 over x, so we have 1 over x log of a to base e plus, we keep this constant and differentiate this constant which is 0, so we have log of 7x to base e multiplied by 0. At the end of the day we have 1 over x log of a to base e plus 0, which is nothing but 1 over x logarithm of a to base e. Therefore, dy by dx is 1 on x e. So this is the result of computing the derivative. Let me take y to be log to base e of 8x plus 1 squared. The question is find the derivative of y with respect to x. The reason I'm giving many examples is is because of what I've always said. The more we practice, the more we learn. So as I'm giving many examples, if you're able to follow all the examples, then whenever you see any problem on any of those topics, you should be able to deal with them on your own, because you have practiced with these examples together with me in the video. So that is the essence of giving many examples. Okay. So what is the derivative of y with respect to x? Again, if you look at what you have here, the first thing to do is to get the setting right. And so we can rewrite y equal log to base e, 8x plus 1 raised to the power 2. We can rewrite it as log to base e of, I want to avoid using u again so you don't feel all times I must use v. I've used v, so let me call it v. Where here v is simply 8x plus 1 raised to the power 2. So if we do this now, our life becomes easy. So y is log to base e of v. Life is easier here because we know how to deal with this, we know how to deal with that. So the derivative of y with respect to x is now the derivative of y with respect to v multiplied by the derivative of v with respect to x. We can compute again. To compute the derivative of v with respect to x, apply the chain rule, because this is function of a function. Alright, so I do with this. It's simple but a little bit lengthy. To find the derivative of v to x, so let me put a question mark to show that we want to find this. Now, our v, I can rewrite v as p raised to the power 2, where p is simply 8x plus 1. The derivative of v with respect to x is the derivative of v with respect to p multiplied by the derivative of p with respect to x. You can see it's application of all that learned, all you know via the video. So we just apply all of them. We differentiate v with respect to p, we get 2p. Multiply by differentiate p with respect to x, we get 8. So at the end of the day, this gives me 16p. Who is p? It is 8x plus 1. That is as 16 into 8x plus 1. That is the derivative of v with respect to x. So we want to apply it here. We know the derivative of y with respect to v. It is simply 1 over v. We combine the two and get the final result. We've gotten our dy by dv, we have gotten our dv by dx. We multiply the two. Hence, by dx, dy by dv is 1 over v times dv by dx is 16 into 8x plus 1. If you like, you can open the bracket and then expand that, so it becomes easy for you to see. And then this is nothing but 1 divided by, who is our v? Our v is 8x plus 1 raised to the power 2. Then multiply by 16 into 8x plus 1. So at the end of the day, this is 16. Let me not plus 1, we divide 8x plus 1, and we're left with 8x plus 1 here. Because 8x plus 1 raised to the power 2 is 8x plus 1 multiplied by 8x plus 1. So one of these will divide one of these, and we're left with 8x plus 1. So at the end of the day, we are left with, let me do this. This is 2 and this. So we're left with 16 divided by 8x plus 1. That is the result of differentiating y with respect to x. dy by dx is exactly 16 over 8x plus 1. That is the result.